Okay, so before we start, this is supposed to be the aviation meteorology class, and that's MET451, and I'll be the one in charge. But before that, I would like you to, if you are using your PC or your phone, you can log into slido.com. Okay, so we have some, let's say 1 minute to do this. Let's log into slido.com first, and then once you log into slido.com, let me see. Once you log into slido.com, so there's this part which says joining as a participant. So you enter the code here, omitting the hash, just the MET451, MET in caps. So you just enter it here and you log in. Now we would need this purely for the question session, so that maybe if you ask your question on the chat, we might not be able to see it clearly. We might be able to, I'm sure we might skip it. But if it's here, it is more well kept, and then we are able to easily identify what the question is and then be able to respond for everybody to follow through. All right, so let's all do this. Let's just go to slido.com and type in the MET451. Okay, are we all done? Okay, so once we're all done, all right, that's good. So when you enter the slido.com, you would have to also change the name. So you can either type in as anonymous, but we want an easy way of getting to know who is writing what, and then we'll be able to address your question well. So change the name. I believe on the top end, on the top right, you would see a button that allows you to change to your actual name. And then once you have that, we are good to go. Okay. All right, so when you get in there we want to try out this first. So these are just for the basic components. Um, so let's see those who have joined. Okay. So Felix, yeah, and okay, Belinda, Nanefua, Prince. Okay, that's good. All right. Okay. So I think with majority of you having it, it means we are good to go. All right. So we would also make use of some simple quizzes. So this is just for you to try your hands on, and let's see if you are very. It's also for the fastest hands first. I mean the fastest fingers, and also purely for your understanding of certain things relating to the continent. Okay. So let's give this a try. All right. Wow. We still had 9% who don't know Ghana's independence. Well done, guys, though. Okay, so that's it. So that's SETMAT 1957. 91% of you got it right. Okay, so okay, so the next one. Try as much as possible to use your own head. Okay. No cheating. All right, so we have varied answers. Interestingly, nobody picked 1442. Okay, let's see. All right, so that's 1482. That's right. And then the very final one. All right, well done. So let's see what the right answer is, which is Botswana. Okay, so let's see who our leaders are. So we have Felix, Fafali in that order. Okay, well done, guys. I mean, you can clap for yourselves. If you have a bottle of water, you can also take it and celebrate your achievement. You've done very well. That's good. All right, so that's it. Purely what we'll be using the Slido for is for interactive session. So like I said, if you have any question, you would have a Q&A point, which should purely be for, I mean, all the questions. So if you have any question, you can type it in here where we have Felix, Jeffrey, and others already making use of it. So if you have any question as the lecture is going on, you can ask it over here, and then myself together with my TAs will be able to assist you with it, with whatever response you need. And officially, I'd like to welcome you all to your first semester final year. It's not been easy, I know. Doing 6 semesters already, and then there's your 7th. It's been a whole lot. So I'd like to say you're welcome, and I hope that the energy that you started the previous years with, you still continue with the same energy. You wouldn't give it up, and we hope that you do the best within your ability. All right, so like I said, this is Aviation Met. If there's any question before we start, then we can take that now. Maybe you want to, all right, so sure, before that, there's one more thing I would like to do, maybe for the sake of those who wouldn't like to talk. So let's try this out too. So what are your expectations for this lecture? So while this is also ongoing, you can still, if you have any question before we start, you can already ask. Okay. Okay, all right, that's good. A lot of varied response and varied expectation. That's good. We hope we'll be able to meet all the expectations you're having. And it also depends on how we collaborate and how we cooperate. So you would be best served if you also ask questions. So as we move on, if you have any questions, don't feel intimidated, ask. It's better to ask and then get to know what the right thing is. All right. Okay, so purely in this course, what we'll be looking at first will be the terminologies, which is when it comes into the field of aviation and then also aviation met, what are some basic terminologies that are used so you don't get confused. I mean, when it comes to the whole structure of the aerodrome, like I said, okay, well, we have an aerodrome, for instance. What's an aerodrome? What are the structures within the aerodrome? How are activities coordinated within the aerodrome and so on and so forth. We'd also look at what we call AMS operations. That's aerometeorological service operations. That's also the same as aviation meteorological service operations. We'd also look at some considerations to be made when it comes to synoptic weather and then how they relate to the airspace or the aviation industry. We'll also be looking at, again, thunderstorms, turbulence, and then some numerical weather prediction. And we'll also look at icing, which is a key component when it comes to the aviation industry. So these are some literature that would help with the course. I would advise you probably have a look at them and then you get more abreast with some basic information with regards to aviation meteorology. Okay, so we can safely start our journey and then hope we will land very safe in this field of aviation meteorology. And so when we talk of meteorology, what comes to your mind? There's the first part, which would be more interactive. So when we talk of meteorology, you've been a meteorology student for 3 years now, in your 4th year. So when we talk of meteorology, what comes into your mind? What do you think of when you hear the word meteorology? So anyone at all? If not, I'll start mentioning names. So when you hear meteorology, what comes to your mind? Okay, Christabel. Christabel, when you hear meteorology, what comes to your mind? What do you think of?
I think it's the study of the atmospheric science, yes. The state of the weather, yes. That's what I understand.
Okay, that's good. Richard, what do you also make of it? Meteorology. When you talk of meteorology, what do you think of?
I think meteorology basically centers on the study of atmospheric conditions of a particular place and then the respective activities of the atmosphere that goes on over that place.
Okay. All right. So let me ask a basic difference between meteorology in general and then weather. Okay. What's one basic difference? One thing you can think of as a basic difference. Love. Okay, Felix. Yeah, Felix. Felix, go ahead. I see your hand up, so go ahead. Yeah. Felix, I think we can hear you. If you can probably check your microphone, go onto the mute button, click on the the drop down or the pop-up icon, and then change to the appropriate microphone so we can all hear you. Okay, so while we wait for Felix, Love, back to you. So when we talk of meteorology and then we talk of weather, what's the clear-cut difference? What do you make of it?
Yes, please, when we talk of weather, whether it's the states of the atmosphere at a particular time, but the meteorology in general is getting to know how the weather comes about or what really brings the weather.
Oh, that's good. That's good. A few other points. Okay, Felix. Yeah, you can go ahead. Hello, Felix. All right, so you try to work on your microphone and then you join in later. All right, Odro Kwarten. So when we talk of meteorology and then weather, what makes the clear-cut difference to you?
Yes, well, I would support, sorry, I'll support what Laf said that weather has to do with the atmospheric condition at a particular place at a particular time. But meteorology is basically understanding the science behind what is happening at that particular place or time. So that's the difference.
All right, that's great. Okay, very good. Joshua, I see your hand up. Okay. Yes, Joshua, please go ahead.
Okay, I think meteorology is concerned with the climate and weather of a region or the science behind the atmospheric condition. But weather is the concerned with the day-to-day atmospheric condition of a particular place at a particular time.
Okay, that's very good. That's very good. Okay, so we have varied opinions, but they are all related, which is very good. Okay, so we can move on now. So basically, when we talk of meteorology, we are dealing with the science of the atmosphere, but then our main focus, our primary focus, is on the weather processes and then also how to forecast it. So that's clearly what meteorology means to us as climate scientists or meteorologists. In another sense, too, you can also say that meteorology is just the science of things in the air, and these include basically everything in the air. So every phenomenon that, like various phenomena that are bound by the atmosphere. So for instance, you look at the variables themselves and how they relate to certain key phenomena like temperature, for instance, air pressure, you talk of water vapor, you talk of purely everything you can think of when it comes to the atmosphere. You talk of aerosols, you talk of various concentrations of matter and so on and so forth. And also we are more concerned with how they change or they evolve, how they rapidly evolve over space and time, or how they differ over space and time. So that's one aspect of meteorology. That's clearly what meteorology focuses on. In another sense, you can also see that it's a sub-discipline of atmospheric science. Atmospheric science is broader. Okay, it's broader, and so we have the meteorology aspect, which is one component of it, and this purely deals with the chemistry and then the physics of the atmosphere, and then also we look at weather forecasting. All right, and clearly, then as the name implies, we have meteors and then logos. Okay, meteors just purely deals with, when we talk of meteors, it's an expression for air, that's the atmosphere, and then logos as a study. And so that's how the word came about. So the study of the air or the study of the atmosphere. All right. So we also say that meteorology is a physical science, and it's a branch of natural science which tries to explain and then also to predict nature's behavior based on empirical evidence or observation. So meteorology is not the same as somebody who is foretelling or giving, let's say somebody who is trying to, it's different from you trying to say, yeah, maybe just assuming or just guessing. It's different from you guessing. All right. When it comes to meteorology, you are given a forecast based on a certain evidence. So you're looking at particular indicators that are telling you that this is the reason why this and that weather is expected. All right. So it's not just a wild guess. You give your weather forecast based on some empirical evidence. And that's purely a physical science component. And so now, once we know this of meteorology, then the real question is, so what is aviation meteorology then? In a simple layman's term, how do you define aviation meteorology? Omari. Yes, Omari, you can unmute and then just talk to us. Okay, Jeffrey.
Okay, so I think aviation meteorology is concerned with the study of the climate.
Jeffrey.
Hello.
Yes, can you repeat the answer?
Yeah, so I was saying aviation meteorology is concerned with the study of the weather to provide weather information to the aviation industry.
Okay, that's very good, very good. Sure, Emmanuel say. Sure, please go ahead. I think Emmanuel, your network is kind of bad. So if maybe you can try typing it, that would do. Okay, or you can reposition yourself and then you come back. All right. Okay. So Felix, yeah, Felix again.
Okay, please can you hear me?
Yes, loud and clear.
Okay. So I think aviation meteorology will deal with the study of the weather related to the aviation industry, maybe to predict whether a flight can take off or it can't take off.
All right, that's very true. That's good. Okay, Grace. Grace. All right, Richard.
I would say aviation meteorology has to do with the study of meteorological operations for smooth airline operations.
Okay. Yeah, that's very true. It's very true. Okay, Kwame Usu. Kwame. Oh. Kwame Usu. Yeah. So what do you make of the term aviation meteorology? When you talk of aviation meteorology, what do you think of? Kwame. Okay, Ebenezer. Sure. Ebenezer. Yeah. Ebenezer. Okay. All right. So that's a good one to I'll say AJ. Okay, so let me see. So if you're on the Slido, I'll just put this up and then you can share your view also on it. Okay. Okay, so you can check on the Slido page and you can type in your answer as we go on. Okay, so we have the question, what is aviation meteorology? All right. So like we said, for all the things we said about meteorology, we are now applying it to the aviation industry. So in simple terms, when we talk of aviation meteorology, we are looking at meteorology that's related to the aviation industry and then also related to their navigation and then operations. So all the things that were listed by your colleagues are exactly right. We are looking at the meteorology itself and then how it affects the aviation industry, how it also impacts on their operations, their movement, virtually everything. And also even the people themselves who are making use of the various aviation modes of transport and all that. So we are looking at basically the whole entirety of meteorology as the complete study of the atmosphere, making use of various, the physical equations, the mathematical computational equations we know, and then also computational power in order to give a reliable information that would be related to the aviation industry and then also their various processes. And so that's in a layman's point what aviation meteorology is all about. And so we look at aviation meteorology, and then this is clearly useful for the day-to-day operations and dependencies of the aviation industry. So without the aviation meteorology, then it means we would have a more limiting sort of aviation industry because they will clearly need the information from the meteorologists. It's not just about takeoff and then landing, but a whole lot of things. When they are even they are already en route, which is they are airborne, they will need meteorological information before they even take off. When they are on the ground and they are doing their regular checks and all that, they need all those information because it gives you a fair idea. As we move on, even into the various components on icing and so on and so forth, you realize that if there's a bad weather, it would have a very huge impact on the aviation industry. And weather is also one of the key components that leads to aviation losses a lot. And so if you are an operator, if you are operating an aviation, let's say, mode of transport, be it for human beings or for cargo in terms of carriage and so on and so forth, you wouldn't want to run at a loss because you are doing the business for profit. You get it? So take operators like Africa World, you take Passion, you take Kenya Airways, all the other ones. They clearly are making profits from the business. So if you do not, if you fail to take the meteorologist information or the meteorology as a key component of your operations, then it means you are on the verge of running at a loss. And that isn't why you would want to do a business to run at a loss. All right. Okay. And so we have this discussion also up. Now, the beauty of this program or of this course is that it has more interaction. And so we get to talk more, we get to express ourselves more, and we get to learn more from each other. And so those who have the mindset of not talking, repent. And then in this class, make sure you talk. All right, so a simple question. This is, how does aviation meteorology impact on the operations of the aviation industry? Okay, aviation meteorology is different from the aviation industry. So we are looking at how the meteorology, when it comes to aviation, impacts on the entire industry of aviation. So you can give us some examples. You can explain in your own words how you, what you make of it. All right. So if you have a response, you can put up your hand and then I'll call you and you can express yourself to the class. So Jeff, let's start off with you.
Okay, so I think meteorologists plays an important role in when it comes to aviation industry. So one of the things they does is that they provide weather informations to the pilots for aircraft operations, especially like writing of the TAF. The TAF contains weather informations which will guide the pilot when he or she is in the air. Then another thing is they also provide expected weather phenomenon that may impose threat to the aviation industry. Example of this is what we experience thunderstorms and maybe CB clouds being formed. They are mostly threat to aircraft operations. So we issue a segment just to inform them that this phenomenon is taking place within this boundary. So they have to avoid that particular boundary. Yeah, so that's what I think.
Right, that's great. That's a detailed contribution. Any other? I mean, for those of us who are following the news, I mean, you recently heard of the storm in the EU. I mean, looking at places like UK and so on and so forth, France, Germany, and the rest. There was a storm named after Eunice. Let me see if there's a Eunice in this class. All right, so there was a storm named after Eunice, and we know the impact of it on the aviation industry, and not just the aviation industry, but generally, you can imagine if its impact on a whole lot of industries was huge. Now, why is it necessary then, for instance, taking the storm Eunice as an example? Why is it necessary that the aviation meteorologist should provide this relevant information to the aviation industry? Why should the aviation industry even depend on the aviation meteorologist? What's the relevance? Okay, so Abbas. Yeah, Abbas. Hello, Abbas. So you can unmute and then you give us your stance on it.
Yeah, sir.
Sure, go ahead, Abbas. Go ahead. So the question is, how does the aviation meteorology impact on the operations of aviation industry? You can share some examples, some observations that you yourself you've also had. Okay.
Yeah, so basically what I've got is regard to their at the airport. Basically the pilot, they've got little knowledge about aviation meteorology, so it is upon the aviation meteorologist to inform them when they are supposed to take off, and if he thinks there is so much that there is a strong wind in the atmosphere or something that is going to affect the taking off of the plane negatively, so that he tells them to maybe how should I even say, maybe pen for now at least, so that for some few minutes, or if he thinks basically it is not going to help them if they take off now, then he's supposed to inform them that it is not going to help their takeoff and they need to relax for a while till he thinks that the atmosphere is quite clear for the takeoff. That is little I think.
All right, that's good. But let me clear something later. Okay, now for you to be a pilot, it means you have adequate understanding of the meteorological conditions. All right, so it's not because the pilot has less or little information. Okay, they are equally informed, but then there's a role that one has to play. Now, if I'm the pilot, for instance, I don't need to also be worrying myself with generation of some information. For instance, the meter, I don't need to be the one generating the tap, for instance. We'll be looking at all those ones. I don't need to be, if I expend all my energies on generating that, then what about transporting the people? You get it? So not because they have little knowledge of it, but because, I mean, there's some segregation in the job we do. There should be some distinction. And so this is where the aviation meteorologist does this as their main job. But then aside that, every other thing you said in there is a good and solid point. Okay, Felix, we'll come back to you, but before that, let's see, Beatrice. Yeah. Beatrice, are you there?
Yes, please, I'm here.
Sure. Okay, so yeah.
Okay, so please, I think that the aviation industry needs meteorological data because the atmosphere is not a calm place or something. It's not stable, and so it changes from time to time. And so if they are aware of what's going on, and then they will know what action to take. Yes.
Right, that's very true. That's very true. All right, so Felix, let's take your point, and then after Felix, Helen.
Okay, so from research, we know that the safest way to travel is through air, that is with an airplane. And I think there was a research that says that 1 in every 9,821 flights, only one case of, let's say, emergency. So with aviation meteorology, if they are traveling, they have to get safety. That means we must actually know what is going to happen in the atmosphere. So the aviation meteorologists play an important role in telling them what is going to happen in the future and what is even happening presently in the atmosphere to ensure their safety.
Yeah, that's very true. All right, so in as much as the aviation industry is the safest, or let's say one of the safest, it still needs, I mean, we still need a bit of caution. And this is where the meteorologist comes in, which is exactly what Felix just explained. All right, that's true. So Helen. Yes, hello, Helen, are you there? Helen Kunama Amponsa, are you there? And then just a quick one, those who have their names not indicated, if your name is showing as iPhone, it will be difficult for us to take an attendance. And so in as much as you would be present on the records, your name wouldn't be captured. So kindly rename yourself, change the name from whether iPhone or whatever phone name it is to your actual name. All right. Okay, Prince Aram. Okay, so then Helen, you can type your response. If your end is very noisy, you can type it. And then Prince Aram. So how does aviation meteorology impact on the operations of the aviation industry? Okay, Omari, that's a good point. I would want you to unmute and then you explain in detail. Your point is a very crucial point. It's very good. You can unmute and then explain in detail. Omari. So kindly unmute and then explain your points in detail. Oh, okay, okay. All right, so just to add a little bit to what Omari said. Now, with the role of the aviation meteorologist, they actually save the airlines some cost. So for instance, if you've probably heard of jets. You studied about jets in tropical meteorology, tropical climatology, and so on and so forth. Now, when you take a jet, for instance, if an aircraft is moving in the direction of the jet, it saves its fuel, because I mean, jets are very fast moving winds. So imagine if you are moving and then somebody pushes you. It means you just go with that flow. All right. So if an airline wants to save costs, they would have to move within the jet, and then they move in the direction of the jet. So then it saves them some fuel. All right. And it makes their journey also quite light. But then if you are moving against the jet, it's like you are moving and then there's a resistance. And so you would burn more fuel. So you need to carry more fuel. All right. So if the aviation meteorologist provides this information to the airline knows which alternative route to take, or which route to take, so that they cut down on their costs. And that's very clear. And that's a reason why we need the aviation meteorological agencies. All right. Okay, so we can move on now to the basic terminologies. So the very first one we look at is aerodrome. When we started, I talked of aerodrome. So when we talk of aerodrome, we are referring to the entire space, what we call the airport. Okay, the entire space. So an aerodrome is a defined area All right, so I think you can still keep your points coming in, all right? So an aerodrome is a defined area on land or water, including any buildings, installations, and equipment intended to be used either wholly, that's fully, or in part for the arrival, departure, and surface movement of aircraft. So when you take the aerodrome as a complete phase, you are looking at the whole rectangular shape, or that whole defined area of land. And it can actually be on the water body too. I mean, sometimes you have some aerodromes or some landing stations on the sea. And even in some cases, you can have some very big ships serving as aerodromes for some fighter jets and so on and so forth. So when you look at an aerodrome, it's purely the area that the airline will be stopping, will be taking off from, together with all its surface movements. When we look at the structure very soon, in some few slides, we'll get to see what the structure of the aerodrome actually is. And so if you look at the right-hand side, you have an image of what an aerodrome looks like. And so within the aerodrome, there should also be, the duty of the meteorologist there is also to provide some climatological summary. And so when we talk of the ACS, or the aerodrome climatological summary, we are looking at the concise summary of specified meteorological elements within the aerodrome, or the aerodrome. And this is based on statistical data. So for instance, we would have some mean information, some variance, some maximum, minimums. And what that helps you to do is, if you're supposed to issue a forecast within a particular period and you need some clarity, it's best to look at the climatological information. So by climatology, we are looking at a long range average, or a long range statistical information. So if you're able to look at those information, then it gives you a better reference to compare. All right. So if I notice that this is what we are observing, now we can look within the climatological records and then see how consistent has this event been, or how different is this event this time. All right. And so clearly that's what the climatological summary is useful for. And we also have the climatological table, which is just a table that provides the statistical data on the observed occurrence of one or more meteorological elements at an aerodrome. So, so those who were at the airport, they also have some charts. If you were also at GMET, for instance, during the internship, GMET is not necessarily an aviation meteorological agency. KIAMO is, that's the Kotoka International Airport Met office. But then at GMET, if you are at GMET and you were in the climatological session, there are records. So they have climatological records, some huge books with also some summary information being drafted, right? And so clearly there's a difference between the table and then the summary. The summary would be probably carved out in a paragraph or like a report form. And then you have the table being like a tabular form of records showing climatological information on the statistics of various atmospheric variables. And then we also have aerodrome elevation. Now for this, as we move on, we'll be looking at some key terms like the QNH. I'm sure I did that with you in second or third year, but we'll look at it again. The QNH, QFE, QFF, and the rest, they come in when we are talking of the aerodrome elevation. So with this aerodrome elevation, we are looking at the elevation of the highest point of the landing area. Now, we are not focused on the lowest point, or we are not taking the average point. Our emphasis is on the highest point. Bear in mind that pressure changes can result in rapid changes in terms of altitude. Okay, and so if an aircraft, for instance, is moving over the ocean, once it crosses onto the land, it has to readjust its altimeter setting, which we'll be looking at in Unit 2 when we start dealing with the meter drafting and the rest. They need to readjust their altimeter setting. So the altimeter setting deals with the pressure adjustments. Now, if I'm moving on the sea, I have a different pressure. When I move on to land, I have a different pressure because of the altitude changes. And so if, for instance, the aerodrome, we are supposed to give the least point or the lowest point of the aerodrome as the aerodrome elevation, then what that means is that we can also have some crash landing, right? Because if the aircraft is supposed to adjust to, say, you know, pressure increases downwards, all right? Pressure increases with depth, and it sort of decreases with altitude. So if ideally the aerodrome is around, say, let's say 998 hectopascal above, that's like 998 hectopascal, and then we input an elevation which is equivalent to, say, 999.5. Okay, that means we are telling the aircraft to rather go further lower before it lands. And it means what would happen is that there'll be a crash landing. I don't know if you get it. It means there'll be a crash landing, but it's better to give the highest point, because if the highest point has a lower pressure, then it means if the aircraft doesn't even make its tires are unable to touch the ground, the pilot can then manually maneuver his way to the ground. Okay, so it's better to always give the highest point of the aerodrome as the aerodrome elevation than using the lowest point. And this is very critical. I mean, for places like, say, Kumasi Airport, Kotka International Airport, you might think it's nothing really huge. But then when you take some aerodromes that are within mountainous regions, it's a very huge thing. And a little error with the elevation can lead to some crash landing. Okay. We also have the reference point. This is in terms of coordinates, looking at if I should pin this aerodrome on a map, where would it fall? Okay, so we are looking at the geographic points, which is the coordinates for the aerodrome. And then we also have what we call the control tower. For every aerodrome, there's an aerodrome control tower. Now, this unit is purely responsible for every movement of any, not just aircraft. They control movements of aircraft within the aerodrome. They also control movement of persons and vehicles, right? So, for instance, if there should be a routine cleaning of the runway, okay, the runway is a no joke area. Now, you don't joke on the runway, because, I mean, that's where, I mean, the airplanes are taking off and then landing. And so they come with very tough speed. And so if there should be a routine cleaning, because that also has to be done, if that is not done, then you can imagine the airplanes can skid off. Okay, they can just skid off. And so there should be routine cleaning. If, for instance, there's a plastic bag, like this poly bag on the runway. Now, when the aircraft is landing, what it does is that it injects, or it sort of ingests within it some air. And these are very huge. So imagine there's a plastic bag, and then it pulls this together with the air that it draws into its turbines or its engines. Then it means it would lead to probably some explosion, some distraction, and so on. And so there should be routine cleaning. Now, for that to be a routine cleaning, you don't just get up and say, okay, I work with the airport, so I'm just going there to clean. Now, it's necessary that you have the required, I mean, you have the go ahead to do that. And the people responsible for doing that or giving the go ahead are the people in the control tower. That's what we also call the ATC or ACT, still the same. So the people in the control tower are the ones responsible for issuing all those directives. Okay, when it comes to movement of vehicles at the aerodrome, aircraft themselves at the aerodrome, which one is taking off, which one is landing, which one is taxiing, which one is on the ramp. They give all those directions. They give all those the instructions. And generally what they do is what we call the air traffic services. That's purely air traffic services. And so that complete unit is the air traffic services unit, which is broader. And it includes beyond just the ATC, also includes the flight information center, and then also other general reporting works that needs to be done. So by the traffic services unit, you're not just looking at the ATC, which is the one controlling the movement of the flights, but even when you take in the airport, for instance, for those who have been traveling a lot, when you get into the airport, you notice that there are various information as to, okay, this is the moving aircraft. This one is delayed. This one is moving at this time. Maybe they are boarding at this time, and so on and so forth. Okay, all those are part of the air traffic services unit, and not just only the one on the runway or the taxiway or the apron or ramp. Any questions so far before we move on? Any questions before we move on? Do you understand what we've done so far? Any question? If you have a question, just show by hand and then you ask. If not, I'll be forced to ask a question. All right, so Francisca, so what have you gathered so far? Francisca. Francisca Mwakwata. Please bear in mind, you are not only rewarded by attendance by being present, your response also counts. So yeah, so Francisca, I know you can hear me now. So what have you gathered so far? All right, Elvis Frimpong, what have you gathered so far? Elvis Frimpong. Okay, so once there's silence, it means everything is on course, so we can move on. All right. Okay, so and on the broader sense, the general Met office is what we call the aerodrome meteorological office. So the general office that's responsible for everything meteorology or weather, climate that has to do with the aerodrome is the aerodrome meteorological office. And a typical example is a KIAMO. So those who are on attachments, those who are having their internships with KIAMO, you clearly know what you were doing there. You were basically working with an aerodrome meteorological office. Okay. And then we also have what we call the flight documentation. Now, this is necessary because this has to do with everything that's written or printed, that's documents that are written or printed, and these are in the form of charts, and then also other writings are issued to the pilots ahead of their travel. Now, the key thing is that it doesn't get to the pilots directly from the Met officer. Okay, there's a whole channel, there's a process. So what happens is that maybe some of you can share your experience as to how you were coordinating this, especially those who are at the CAM. I know some of you were there. I know Jeffrey, you were there. What's the other person? Is it Benedicta? I know Benedicta too was there. So and Emilia Provençal, you can also share your experience. So what you do is basically after you've drafted the entire information, you would issue that to the operators, which is in this case if it's for instance Africa World, you issue it to Africa World. So they would probably call in or move to your end to get it, and you would issue that to them. Now, when you're done, it's their job to make sure it gets to the pilot. And so they also have their own processes that they run through. Then aside that, you also issue the same information either via, an electronic means to the traffic control, the control tower. You issue that to them, and then it's their duty to then also use that information together with, the spacing and then the movement around the aerodrome to give further directives or directions to the various airlines. Okay, so maybe you could share your experience with us, Jeffrey. When you were there, what were you doing? What was the procedure like? How did you get information to or if probably not even you yourself, how were they doing this per your observation, what you saw? How was this whole thing being done when it comes to documentation? Yeah, Jeffrey. Hello, Jeffrey. Any other person who was at the airport to share their experience with us? Benedicta. Benedicta. All right, Stephen, yes, please go ahead.
Okay, so I was at the Kumasi airport, and basically what we were doing was that in collection of the data, we go to the enclosure, which is very close to the runway. We go there to pick the weather data, and then we come back to the aerodrome, that is the office, MET office, and then process the data. So we have weather calculator over there to process the data, and then after the data is processed, we first of all give the data to, the processed data to the tower. And so the tower will pick the data and then sometimes give it directly to the pilots, or other times to the airlines will call directly to the MET office and take any current data that is available. And this is mostly done every hour. And so every hour, airlines will call for data, and we also have to process the data and then give it to the tower. Yes, so that is basically what we're doing there. And after giving it to the tower, you have to book everything. At first, we used to write the collected data and everything that we have processed. We book them in a very big book. But now everything now store all the data on the machine over there. That is the laptop. That is where the data is now stored. And mostly after it is stored, Accra Met, they call for the data during the synoptic hours. And then sometimes to other airports who also call, I mean, something like the Tamale airports or Takrade, they will all call for data. Sometimes to farmers who also call for any data that is they may need. Radio stations may also call for data. Yes, so for with regards to aviation, mostly we give the data to the tower, or sometimes the airlines also call for data. Thank you very much.
Okay, sure. Thank you. So there's practically somebody's experience that was shared. So yeah, thanks, Stephen. Jeffrey, I think you got the question now. Do you want to also share your experience? Belinda, to is it Benedicta? Would you like to share your experience with us?
So
Yes, go ahead.
Yeah, painting.
Abbas, I thought you were talking, so you can go ahead if you have something to say.
Oh, sir. No.
Okay.
Yeah.
All right, Jeffrey.
Of the airport.
Oh, okay, sure. Jeffrey, go ahead.
okay, so most of the time, we write the TAF, then send it to various airline stations. So for instance, we write the TAF for Accra, then Kumasi, then Tamale, and that of Wa. Then after we finish writing the TAF, we have a system where we send this information. So we go to that particular system. They basically based on their IATA. So we transmit the tab to Kumasi and then to various places that we have written about. Then also another way that we transmit to the airlines is when it comes to the flight folder. So the flight folder is contains it most of the time contains the TAF information, the meter information, and also when it comes to another chart, the wind direction and those charts. So we receive this information, we print this information. Sometimes we don't print for the flight folder, we don't print it out, but then we transmit it to the airline. Sometimes we have the same email. So if you go to Accra like this, they all use the same email. So when we get the information, then we print it out, then we transmit it through email to the real transmit the
Okay, so Jeff, that's quite good. I think somebody has a question here. I was hoping that the person would have so Prince, I think I would address your question when you post it to everybody. Okay, so post it so that everyone will be able to get to see what you're asking, and then it will be easy to respond. Okay. But it's a very interesting question. So Prince, you can post it to everybody, and then Jeffrey will then address that. Okay. All right. So we also have, I mean, guys, thanks for the contribution. That's very true. So exactly what it is. Now, you talk about IATA, right? Jeff, you talk about IATA. Can you tell us what that stands for? What is it?
Okay, hello.
Yes, please go ahead.
Yeah, so we have various names for various places. We have the ICAO and the IATA. So the IATA basically means the International Air Transport Association. So that is that for that one, it is international. So since Accra is an international airport, the IATA name for Accra will be for it will be it has a name for that. Then also the ICAO is basically for local kind of airlines. So the ICAO is just International Civil Aviation Organization. So for that one, Tamale like this as a code name. Kumasi also has a code name. Then other places who has a code name. But then for the IATA is for international. So when, let's say for instance, from let's say Gambia to Ghana. So in the whenever they want to indicate your where you are departing from, or where your destination will be. So you are departing from, let's say let's take Banjul Airport for instance. Then your destination will be Accra Airport. So for that one, the is ACC. So that will be the IATA name for Accra.
Okay.
Yeah, but for the ICAO is for like local ones, like Accra communicating with Kumasi. So for instance, when we want to transmit the TAF to a particular place like Kumasi, we indicate the IATA name for Kumasi. When we want to transmit to that of the Tamale, then we also indicate the IATA name for Kumasi and the rest. So that's the
Sure. That's great. And then, so just to add on to that, by way of question, so Prince is also asking. So he wants to know, when you were talking about the calling, okay, where you said the airlines were calling. So he's asking if, for instance, we have a plane coming from, say, US to Ghana, but currently they are in US. I mean, do they just take off? And then while they are in the air, they then call into Ghana to find out whether it is, I mean, what the parameters are, is it safe to land and all that, or they sort of communicate way ahead of time?
I think they communicate ahead of time. So most of the time, before we send the staff information or the especially the flight folder. So let me take the flight folder for instance. The flight folder contains the TAF information, the meter, and the rest. So before we send that, maybe there is a flight moving, is going to set off at maybe 14 hours. That is around 2 p.m. right? So we send the information to ahead of time. We send the information to them, let's say an hour or maybe some 2 hours before time.
Okay.
So that they can take off. Then another thing is that so with most of the time when let's say for instance they are taking off around 2 p.m. and we want to send or transmit the information maybe 5 hours before 2 p.m. Most of the time the system will tell you that constant, it is always changing. So you have to wait for hours closer to 2 p.m. before you can give them the information ahead of time.
Okay, so so clearly, Prince, so the question you asked, I know clearly one of the yes, I think also some of your mates should be able to respond to this. Those who were in Kumasi, is Preska here? So Preska, you can share your experience when you went to the airport. What did you also observe when you went to the control tower? What did you observe? Yeah, Preska. Hello, Preska. Yes.
Hey,
So do you mind sharing your experience? What did you observe?
I also saw that they were taking readings, being its temperature, pressure, and then the speed of the wind before sending and the control tower.
Preska, are you done? We didn't hear you. All right. Okay. Sure, Daniel. Yes, Daniel. Daniel, so share with us your experience when you also went to the Kumasi airport. I mean, with regards to the information transfer, how was it done? Did they call ahead of time? I mean, what's the whole procedure like? Daniel. All right, so I think pretty much everything has been already shared. So the various information that they shared with all of you, that's clearly what the procedure is. So before you even take off, you need to be in touch with definitely your, I mean, departing aerodrome, you need to be in touch with them. But then your airline should also be able to make some communication. So for instance, in Ghana, for instance, what happens is if you get a chance to be at the Kumasi airport and say maybe Passion Air wants to land in Kumasi airport, before they even take off, they would already get in touch with the ATC in Kumasi and then find out what the conditions are. Okay, so they get to know what the conditions are, whether it will be safe for landing within the particular time they would want to arrive. And then they also take the same information from their departing aerodrome. And so they have various information on the start and then the finish line. And so once they are given the green light to take off, it means they are good to go. And depending on the altitude that the aircraft is flying at, if mostly the chaotic events or chaotic happenings will be in the very lowest part where we have a lot of boundary layer interactions, okay? It will be in the lowest part. And so once that is happening, it means when they go beyond those particular low level clouds, that means they will have less distractions. And so mostly the emphasis are on the starting and then the stopping point. But then that notwithstanding, if they are even airborne, they still would need some information. So the airlines that we have now, I mean, the airplanes we have now are sort of equipped with very active sensors that provide some information as we move on. So they've got radar system, they've got some other laser form of systems on them that tells ahead of time where they approach, whether they are approaching a storm, a system like a CB cloud, and so on and so forth. All right, so that's purely the process. And so we move on to the next point, which is the briefing. Now, this we all know because we're all at GMET between our second year and third year. So you don't say you're going for what's the name? Observation discussion, but rather you're going for briefing. Now, by briefing, you are just going through your the documentation you're having and then also the observation you're having, and you are discussing it. So it's a form of deliberation or a form of commentary, right? And you are discussing what the salient points are, what are the observations, what are the things we expect along the path while we travel. But we don't call it a discussion, we call that a briefing. Okay, so there's a briefing and then a debriefing session for every before every flight takes off, and then after they land, there's also a debriefing session. And aside that, we can take this also beyond just the meteorological station and even look at what happens with the pilots themselves whilst they are on board. Before they take off, you always have the captain on one end and then the first officer. And in most cases, depending on how big the airliner is, if it's a very huge passenger airline, that means you might have one or two extras in there who would also be playing other roles. But then what happens is that whilst the one is doing the check, the other is also making sure that they have quality information being transmitted to them. And once they are certain, in fact, that whole procedure of getting the information is what we call the briefing. And even amongst themselves, before they take off, before they land, they also have, more especially before they take off, they also have their own personal briefing session, all right, which is purely an oral commentary. And our next point is what we call the alternate aerodrome. We already know what an aerodrome is. We've talked about the aerodrome, and so we know what the aerodrome is. Now, they are what we call the alternate aerodromes. So before an airline will take off, before an airline will take off from a particular aerodrome to another aerodrome, depending on what the conditions are expected to be. And even in most cases, because we know that weather can change very drastically, we provide alternate aerodromes. Alternate, as the name implies, is just an extra. An alternate aerodrome in the sense, so an alternate aerodrome in this case will be an extra aerodrome. So we have them in three forms. We can have one, the takeoff aerodrome. That's if, for instance, an airline is supposed to take off at a particular place, but because of bad weather, so maybe it ended up landing at a different point, then it means that wasn't its original point to take off. So let's say we had an airline which was heading, there's an airplane that was heading towards, say, maybe Heathrow Airport. And then upon getting to Heathrow Airport, realized maybe there was a severe storm. So it ended up landing at, say, Gatwick. All right. It ended up landing at Gatwick Airport. Now, Gatwick serves as an alternate. And that's purely because it was landing there. So it became a destination aerodrome. But then when it's taken off, ideally for the passengers who were coming in, their idea was they're going to take off at Heathrow. But because of the change, because they are now going to take off at Gatwick, Gatwick is serving as an alternate aerodrome for takeoff. And so that becomes a takeoff alternate. All right. And then also, more importantly, let's say for some cases, if there's an emergency, for instance, let's say, I believe you watched this movie before. Maybe it will be a good explanation. For instance, you watched Three Idiots. When they started, I mean, somebody had, even though that one was fake, but there can be instances where right upon takeoff, somebody has an emergency, you know, they need to bring the person back to the ground. If it's a medical situation, because they've not gone too far, they will then have to come back. If there's, for instance, while they are about taking off, in fact, when they just take off, they realize maybe there's an engine fails, or a flap is not working, something is gone bad, then they would have to probably land, and maybe they might not come back to where they took off from, but they would, but then they will land in a different aerodrome, and that's where they are going to take off from afterwards. And so that becomes the alternative or the alternate takeoff aerodrome. All right. And then whilst they are en route to, if there's an emergency, whilst they are moving already, they are already airborne, they are en route, and then they need to land. Okay. Previously, we used to have a whole lot of these happenings. For instance, you have an aircraft going a very far distance, and because the aircraft is not built to have huge capacity for fuel, then it means it has to refuel along the way, along the journey. So there is always a provision of an alternate aerodrome where they go and then get to be refueled. And then the destination is, for instance, you are having an aircraft coming to land in, say, Kumasi, and then by the time it gets to Kumasi, it notices a bad weather, so it moves all the way to Tamale Airport to land. Tamale then serves as its alternate destination aerodrome. Okay. And this is clear. We've seen this before, where, I mean, an aircraft that was airborne already heading towards Kumasi Airport, and then there was a significant change in weather. And so at the points, they had to go back to Accra. Okay, so all these information are provided. And so depending on what we are looking at, all these are alternate aerodromes, but then it becomes a takeoff or en route aerodrome or destination alternate aerodrome based on the reference. Okay. And then also we'll be looking at this in detail. So when we talk of altitude, we are looking at the vertical level from mean sea level. That is different from the aerodrome level. Okay, it's different from the aerodrome elevation. So altitude, and this is also clearly different from flight level. We'll look at all those in detail as we move on. So by altitude, we are looking at the vertical distance above the mean sea level. All right. And we've already seen what the AMS is, typically the same thing here. So station that is in charge of meteorological reports and so on and so forth. Okay. We still have a couple more to look at. So I would pause over here and then take some questions if there are any. Yeah, Stephen, please go ahead. Yes, Stephen, you can go ahead. You can unmute and then ask your question.
Okay, sir. You said during a large passenger airline, some of we have alternate pilots who serve as
Like
who support
backups.
the main
Yeah.
pilots.
Mhm.
So, sir, during the briefing,
Mhm.
what if the information that they get from the control tower ahead of time? What if the weather changes? Since weather is changing rapidly, what if the information tends to be false or incorrect or something? What
Okay,
would
so
happen?
all right, so that's a good question. Now what the meteorological agency uses, it's not just observation on the ground. So we are looking at a combination of different things. So we are looking at satellite-based information. We are looking at ground-based information. We are looking at in some cases, some modeled information. All right. So we know the weather wouldn't be static. It changes with time. Now, is this in most cases when the airline departs from your airport, okay, it's no longer within your jurisdiction. So you have a radius within which you control it. All right. So it's no longer within your jurisdiction. Now, when it's moved out of your domain, it goes onto the bigger network, which is our GFS. It goes onto the bigger network. Now, the GFS, what the GFS does is it has information from all, it's like a whole global forecast system or a forecast unit. What it does is it keeps information from all aerodromes. Okay, so for instance, if you are Kotka International Airport, when you are done, you have to log in your information. If it's a meter, if it's a TAF, if it's a segment, you have to log that on via what we call the GTS, the Global Telecommunication System. So once you log onto, once you key in the information, it moves directly onto the GFS. All right, and so we have GFS information all over the entire globe. Okay, so if I'm moving from here and there's any change, now the GFS information has captured the change because you are rapidly updating. The aviation meteorological agencies are rapidly updating. Okay, so once there's an update, it means it tells me what's ahead of time. I'm able to know if there has been a change, a drastic change based on the subsequent information I'm having. So it's not just the paper they carry with them. The paper is just a background, okay, to give you key severe events. But as you move on, even the current airlines are built with more sophisticated tools that would help you to deduce or sort of identify certain key weather changes. Yeah.
Okay. Thank you, sir.
You're welcome. And then I think, Prince, your hand was up. Is that the same question you wanted to ask?
Yeah, so it's answered.
It's answered.
I wanted to ask whether, like, when the flight is in the air, like, do they communicate with other stations? Let's say if from US to Ghana, after communication.
All right. So yes. Okay.
While they are in the air, like, do they like find if they find themselves in a difficult situations, do they like call in again, or they remain just like they don't call in again?
All right, so is this, so before you even make your journey, you are given what flight level you are moving at. So now is this, I don't know, maybe I could just show you what's happening even in real time. If you go on to, I hope I remember this flight radar. If you go on to flight radar 24, for instance, you see what's happening in real time in terms of airplanes that are moving in real time. Okay, so if, for instance, you are supposed to be on a particular flight, you would be able to track its movement and so on and so forth. All right, now what happens is that when you're airborne, the number of airlines are huge. Okay, and bear in mind that we can't, like, the MET station, it's already serving a huge number of airlines or sort of operators within its own airport. Let me share this with you so you just get to see. So this is currently what's happening. I don't know if you can see it. So there's currently, like flights that are either on ground or airborne. In most cases, these are just flights all over. Now imagine if you are probably in charge of, if you are somewhere here, somewhere maybe controlling within Ghana, even Ghana, actually, there are peak hours. Okay, mostly at night, it gets very like loaded. You have a lot of airlines coming in. Let's say if you're at Kumasi, Kumasi, you might be able to control both on the ground, and then if you want to even control above, you might, but that's not an ideal thing because there's a particular vertical altitude that they are now not within your airspace. All right, unless of course there's an emergency, that's when they'll be able to communicate with the aerodrome that's directly on the ground. Okay, and like I said, all these aircrafts are built with various sensors, sort of devices that are very super in terms of communication, and also in terms of identifying some extreme weather phenomenon. Okay, so it's very it's not as though when they are airborne they'll be talking with all the individual control towers on the ground. No, that's not the case. So they start with their departing ATC. Once they are done and they are airborne, everything they are doing is directly with the global system. That's the GFS. They are directly with the global system, right? And then if they now need to make some emergency landing, that's where they would have a communication with an alternate aerodrome and then find out if it's necessary if they can be given the go ahead to land. All right. And so that's it. I believe your question is answered. Any other questions so that we can quickly wrap up? We'll be wrapping up on this slide though. So if there are any other questions, you can ask now. Okay, so Stephen, yes, your hand is still up. Do you have another question? All right, Felix. Oh, Stephen, do you have a question?
No, sir. No, sir.
Oh, okay. All right. Prince, your hand is still up. Do you also have a question?
I've got a question.
Yes, sir. Sir, I wanted to know, like, do they get they get wrong information? Do they normally get wrong information while they're
while they are airbound?
Yeah.
So the probability is very, very low. Okay, probability is very, very low. Now the peak, like I said, one of the key things, if you have an airline that's moving somewhere, above, in most cases above 11 kilometers, that's almost at the tropopause, and then slightly, maybe in most cases even slightly above. Extreme weather phenomenon would only be associated with, in this case, some jets, right? But the duty of a jet wouldn't be to bring the aircraft down. So it might only cause some turbulence. Okay, and extreme cases of turbulence would not even kill. There's not been, unless maybe I'm mistaken, there's not been on record any clear case of turbulence killing somebody. There have been some injuries, there have been some damages to some parts of the aircraft, right? So if they are airbound, probability of having some extreme weather wouldn't be so much, let's say, rainfall dependent and all that. You might be only looking at jets, all right, and some turbulence, all right? And once you're able to map out your jet positions, and also bear in mind that when we go into the upper atmosphere, okay, most of the mixing components of the lower atmosphere is already reduced. You have more stream flows, okay? And so once you're able to map a jet position, it's easy to know that, okay, there will be some turbulence at the entrance or the exit of this jet. And so in most cases, it wouldn't be too huge a disparity when you issue the forecast, okay? However, it's necessary. One of the key things we'll be looking at is when we talk of, for instance, clear turbulence wouldn't give you any signal. So in most cases, what they'll be missing a lot will be clear air turbulence, because you see the atmosphere being normal, okay? And then you just move in and then you experience some turbulence. Now, those ones, you can't directly forecast them. Okay, you can only have some indicators, but you can't fully map all of them out. So in terms of forecasts, reliability when you're going into the upper atmosphere seems to be very good. And so with minimum error, even though there are still some error margins, but they are relatively minimum as compared to what's happening directly on the ground. Okay. I believe your question is answered, Prince. Okay, so Abbas.
Yeah, sir.
Yeah. Yes, go ahead.
Yeah, so my question is regard to what's up with aviation meteorology, aviation industry, and airplanes going missing.
All right, so that's actually a broader component. In fact, they've been given different reasons. There have been different reasons for it. Okay, some have been linked with some gravitational pull, for instance, in the so-called Bermuda Triangle. Okay, which still is a mystery that hasn't been fully understood yet. So there could be some basis for they getting missing. All right. Now, in most cases, what happens is that they just go off the radar. Okay, as to what the reasons are, it cannot be fully explained. All right, just by the cases we've experienced. And like we already started by saying, some of these accidents or some of these stories or some of these things we hear, which are real life happenings, they are just on the minimum. They are just a few, right? So there are still, I mean, some current studies that are going on into it, but the only reason or the predominant reason that most people have linked that to is just some sort of gravitational pull within particular portions of the earth, right? That's purely it. Okay, so if you even look at, for instance, there's this particular phenomenon that deals with the oceans. You've got the ocean, and then at a point there's a pool. You have this sort of a vortex. It looks as though you are, let's say when you get onto your toilet seat and you flash, how it rotates and then it forms a hollow point and drills down, just like you have a typical, let's say, thunderstorm, how it looks like. Okay, I mean, your hurricane features and the rest, how they look like. All right, so it's purely something like that that has been given as a reason, but that is not fully confirmed. So we can't scientifically take that as the pure reason. I don't know if your question is answered.
Yeah, yes, sir. Yes, sir.
Okay. All right. Winfred.
Okay.
You said?
Yeah, my last question. What we basically see in movies that people, those on board go off board with parachute, like every single person on plane goes off board with a parachute. Is it real? Or it's
Goes
just
off board. Okay, so now, so is this Dion, if you have no question, kindly mute your microphone. Okay. All right, so it's this. I like the way you ask the question in movies. All right, so that's purely movies. Now let's come to reality. Okay, there are some cases that are real. I mean, for instance, if it's a fighter jet, then those ones they have to have those as backup. Now, if you can probably take the chance, I mean, try to travel from maybe Kumasi to Accra, go with Passion Air or go with Africa World and just experience it. So what you are given is just a live vest, okay? You are given a live vest. Now it is directly under your seat, and what you are told ahead of time is just the directions, okay? So for instance, they tell you the do's and then the don'ts, and then in the case of an emergency, if there should be, say, a crash landing, if there should be a landing over the sea, what you should do. Now you're only given a live vest. A live vest is not a parachute, so you can't take your live vest and say it's a parachute, so you are jumping out. You get it? Okay, Winfred. Yes, Winfred, go ahead.
Yeah, so like in the case if there's hello.
Yes, go ahead, we can hear you.
Yeah. So in the case whereby like there's a plane on the high seas and like it runs out of fuel and they're supposed to land.
Is that there's a plane where?
What are the like let's see you are flying over the high seas and like something happens, so you have
Okay.
to land. But there's no place to land. There are no islands on the horizon. Do you have to like crash land into the ocean and call for help or something?
Okay, so I like the imaginative part of your thinking on this. All right. Now, one thing you should know, okay, which has been based on some empirical evidence, is that if before you move, okay, I don't know what the reason would be for which you are coming down over high seas. If it's full, you are fueled adequately because you are given adequate information ahead of time to fuel yourself. I mean, for your carriage to be fueled. All right. So that cannot be a clear reason. Okay. But let's assume for the sake of assumption, okay, that's the case. Now, mostly if I'm flying, for instance, within a jet, okay, that gives me an extra push. That's why also aircrafts don't just fly close to the surface. They fly at a particular altitude. In most cases, for instance, the very bigger passenger airlines, they fly at a very high altitude so that even if there's anything at all, you still have some leverage of space to cover. All right. And get to know that the speed at which the aircraft moves is way in multiples of a normal vehicle. All right. So it has enough coverage before it would even come onto the ground. Unless, of course, you are coming with the nose of the aircraft down, okay, which is like what happened in Ethiopia recently. I think somewhere 2019, where we had the aircraft moving from Kenya to Ethiopia, and then they already crashed because they were now getting used to the new types of the Boeing aircrafts. Okay, but then aside that, if you are on high sea, I mean, if you are moving within a jet, it still gives you some leverage to cover before you come down. So it's strategic. That's why they move at that high altitude and not just close to the surface. All right.
Yeah. So, and another question, like if there is space, debris, and junk entering into our atmosphere,
If there's what?
how if there's space, debris, and space junk,
okay,
that's being put towards the earth, that's entered into the atmosphere, like it's within the airspace, would they alert them?
Would they alert?
Yeah.
I'm not getting the question. So, like, you have a space debris moving on to. So, in most cases, you know, the Earth's atmosphere serves as a filament. It doesn't directly allow it to get into the Earth space. But let's assume that it's happened, okay, which in most cases it has been argued that, for instance, like the Lake Bosomje crater, which has been argued to be one of the, has been linked to one of these events, all right? Now, after all, if you are the Met service, I mean, you are not just working in isolation, okay? So everything in the atmosphere, there is information on it. Okay, and in most cases, if there's a space debris that would be coming, that's information issued in the, let's assume that's going to happen. It's an information that's not necessarily needed to be issued by the Met service. It's an information that would have to come from the space agency. That's why there's an International Space Agency, which is responsible for everything outer space. You get it? All right. Okay, yeah, Felix, you can ask your question.
So I checked the site and I realized that almost all the flights have a unique code. I think they are like 7 or 8 values. And I also realized some of the flights are yellow and some of them are blue. So I wanted to ask why are some having different color codes?
No, that is purely how the interface works. Okay, so the interface has its own. I haven't really studied it to know, but probably when you click on it, you might know, you might find out some information, whether it's if it's based on the type of the airline, it's based on whether it's in motion or not. There could be a reason for it, but I haven't looked at that. Now, Flight Radar is just another, it's also like another company that's doing its own work. So they will have their own reasons for doing those notations. Yeah.
Okay, thank you. Thank you very much.
Sure, you're welcome. Yes, Prince.
Sir,
sure.
You were talking about crashes, and in some cases, like some planes, not And you make reference of the fighter jet, but actually the fighter jet normally has like its parachute beneath the seat. So anytime there is an emergency, the pilot just ejects. So I don't think there is a need for going for a parachute. But in commercial planes, like they say they have one which is located in the cockpit. So
Yeah.
sometimes if let's say if the pilot like does a mistake and the plane is in, let's say trouble, like does he try to escape without parachute or
No. So
because in the cockpit I can't get it clear.
no, if that's the case, then it means there won't be some act of fairness. You get it? So I mean, every airline agency conforms to a certain code, right? Certain given code. Now, if that's the case, then I mean, every pilot will just decide, maybe I want to kill all these people, so let me just go with them and then dump them. All right, you get it. So that's not the ideal case. That's not what it is, right? Like I said, what you mostly see in various, there might still be parachutes that we can't take away. I mean, for particular reasons, but what you see in a passenger plane, mostly you have just the life jackets. I mean, the life vests, which you are definitely given a drill before even the flight takes off so that you know what to do when it happens. And then again, I mean, fighter jets, like you said, I mean, under the seat, but then, you know, there are different types of fighter jets. And so, I mean, they come with their own design and then their structure. And then also, I mean, for majority of the times you see people with parachutes, it means people who are just going on some sort of gliding and all that. All right. So they are doing that as a sport. You get it? That's purely the majority of the cases that you see with parachutes, I mean, on a large scale. Yeah. But that notwithstanding, it doesn't mean that for all the ones we've listed, we can't have them on it. Okay. All right. So Jima, please go ahead.
Okay, sir. My question is, why would planes be moving at high altitudes when the winds they are very strong and destructive?
Okay, so when we started, I indicated that is this. Now, you wouldn't want to move in the lower part too because that's where you have a lot of chaotic weather. Okay, so if you're having more chaos in the lower atmosphere, then it means you would rather want to go a bit higher where there's some, you know, just a minute, please. All right, so if you are moving in the lower atmosphere, I mean the troposphere, that means there's a lot of rather more, you know, turbulence activities and all that. I mean, you have more chaotic activities. Rain developments will be here more. You have lots of CB clouds, a lot of cloudiness, and that would also be obstructing, you know, visibility and all that. So, I mean, if we are up there, it serves a lot of purposes. One, you have a clear space to be able to see within because you have less cloudy conditions, so visibility is more improved. It's very advanced. And then aside that too, if you have the jets, for instance, the jets, if you are lucky, the jets can serve as a benefit and also as a negative. If you are moving in the direction of the jet, then it means you, the airline, you save costs. You actually will cut down costs. So a journey that should probably take about 15 hours, you could spend say 10 hours, 11 hours because you're moving along the jet. And these jets are moving very fast. So you get to move faster and then you save fuel, you save cost. But then it becomes a negative when you're moving against the jets. All right. But then another key thing to note is that turbulence, you can't do away with turbulence. Once in your, say, maybe if you fly about 100 or 200 times, there's a probability you'd experience turbulence. Like I said, turbulence doesn't kill. It's just like you moving through a portal. If you are driving your vehicle and move through the portal, it doesn't kill you. But depending on how deep it is, you might have some injuries. All right. And so that's exactly what the turbulence does. So moving at that high level is more advantageous to you as an aircraft than even rather moving in the lower parts. You get it? Jima, is your question answered?
Yes, please. Yes, please.
All right. Okay, so if there's any other question, we take it. Just room for one more question. We make room for one more question. Yes, Prince, please go ahead.
My last question is about the engines. Like, why do commercial planes use four engines?
Why do they use
four engines?
Okay. Are you done? Are you
Yes,
done with
sir.
your question? Yes. Okay. So, I mean, it's purely for its capacity sake, right? Most of the commercial planes, if you really do a probe into them, they can even run with two. They can run with two because most of these engines are also very huge. They have huge capacities. But a key reason why you have four, there could be emergency situations where maybe one would die out. Then there's a backup, it can 7, but then you are still making use of all of them. Each one has a huge capacity to run. Okay. In cases of emergency, there could be a support easily. Aside that too, now if they are, if you have 4, even in more recent cases, there are others with about 6. When you look at the, I think a classical example is the A380s and beyond. Some of them are 6 and even more powerful ones. Okay, so what happens is that if they are running on these, they make fuel consumption more effective. They're able to, the negative of it is that if it's not running clean, okay, which is the goal now, particularly with the UN SDGs, if it's not running clean, then you are also polluting more. But if it's running clean, then it means it saves you a lot because your fuel consumption is lower. Now, you can also then have capacity to store or to hold a huge number of, passengers. Okay, most of the ones that you see with very huge or sort of multiple engines have the capacity for wider capacity of people, all right, or passengers. And so these are some of the reasons why, these passenger airlines would rather opt for multiple forms of, the engines like 4 and beyond. Okay. So is your question answered?
Yes, sir. Yes,
All
sir.
right. Okay, so this is where we'll end today's session. It's been very interactive with all of you, even though some of you were not talking. We'll have our next session. We'll communicate whether it will be via Zoom or it would in person. All right. So let's still keep our fingers crossed and then we see how it goes. And do well to also research more, try to read more. In fact, aviation meteorology is a very interesting topic. Once you're able to do your research, you're able to research wide, you find more relatable things. You realize that when you're at the airport, even if you get to the airport, it makes it more fun. And a combination of aviation meteorology with your satellite and radar meteorology gives you a more holistic experience, especially if you are flying. When you get experience, you get a chance to fly, which of course, most of you would want to go and do your master's, your PhD in other places. And even some of you would want to travel. Yes, so I think this is just in person. Some people will travel by aeroplanes and other people are traveling by other things. So you know what we are talking about. So whichever one you opt to travel with, you would want to rather, have a fair appreciation of what the course is, the meteorology, that's aviation meteorology, and also the radar, and then the satellite meteorology, and all other components that you've looked at. So let's do well to read more, read wide, and then have more questions. When we meet the next time, we'll be able to make it more interactive. Okay, so have a great time and a good evening. Bye-bye.
Bye-bye.
Sure. So the recordings will be made available to all of you so you can share it with your colleagues, those who are not able to make it. All right, sure. Bye-bye.
Okay, sir.
Okay.
Wait first. Stop
Sir,
traveling by
please, what about the PDF?
Tyro.